instantaneous rate of change. So going back to this right here, your average rate of change, if you remember, is the slope of the secant line. It was just an average, and all you'd have to do is take f of b minus f of a over b minus a. Okay, and you had some curve, and you would take this point A, this point B, and you'd find that average. Okay, it was good. It was a good help for us, but it didn't find us at the exact moment we need, at A being, your time being 2 hours or 2 seconds. So then we figured out, if we do this whole idea of limits and we put a limit in front of it, then we have the exact moment in time that we need, which was called the slope of the tangent line, which was f of a prime, and we would take the limit as h goes to 0 of f of a plus h minus f of a over h. And so that helped us find this curve right here and find this exact moment. We could find finally the slope of that tangent line, and it was wonderful. So let's now apply this to a position. So we're going to let s of t be what's known as a position function. Your s of t is your position function of an object at a time t, t usually being seconds. Your velocity, which we call v of t, is very easy. It's the first derivative of your position function. That's all it is. Your velocity is the first derivative. The rate at which the object is going is increasing or decreasing at a certain moment in time. That's what your velocity is. Very simple. Again, in physics-based, if you take physics, you would have to do like a whole bunch of algebra 2 stuff to figure that out. Speed is the absolute value of velocity. Absolute value of your velocity. We also call that in physics, we call that magnitude. When you see absolute value, it's the magnitude of velocity. Sometimes they'll use that word. What's the magnitude? Then acceleration is the rate at which the velocity is changing. I'll say that again. Your acceleration is the rate at which your velocity is changing. So we write that as a of t, which is the rate at which velocity is changing, which is known as a second derivative of the position function. Acceleration is the rate of change of velocity. So we are going to do an example, a very easy example. We'll do another one, and then I'm going to throw you some business information here, and it's going to be done. And this is a very common example. A ball is dropped from a height of 64 feet. Its height above ground, t seconds later, is given by s of t equals negative 16t squared plus 64. Okay, so you're dropping this ball from a height up here down to the ground, and we know that it's 64 feet up high. Okay, so what is the instantaneous velocity of the ball when it hits the ground? There's really two parts to this question, which I'll talk about in a minute. First part is very easy. When is the instantaneous velocity? What did I just tell you velocity was? What did we just look up there in your notes? And what do you have to do? Derivative of s of t. By the way, just real quick while you're doing that, do you know why there's a negative 16 here in front? Yeah, so if you haven't heard of this, your position function will almost always have a negative 16, especially if we're talking about the force of gravity upon you. Gravity impacts you at negative 16 feet per second. If it's in meters, this would be like negative 9 point something. I can't actually remember. But when you take physics, that's really the only thing that usually changes when you're talking about things going in the air and coming back down. This is from the impact of gravity on us. All right, so what's the instantaneous velocity? That's easy. Take a derivative. It's all you got to do of your position function. So it would be negative 32t. Do you all agree? Easy breezy. Now, but that's only the formula to give me velocity. I need to know what is the speed at which it's hitting the ground. What's the speed at which it's hitting the ground? Do you know when it's going to hit the ground?
0.
When what is 0?
Y.
Very good. We are at a position right here at like a position of 0. Would you agree? Ground level 0. Have you heard of that before? So I need to know what was the time that it became 0. So I have to go back up here and set my position function, my y value, equal to 0. And just solve for t. So negative 16t squared equals negative 64, t squared equals 4, take a square root. T is plus or minus 2. It's not ever minus 2. Do you know why? You can't go backwards in time. You're not the Flash. Okay. Sorry. Okay. So t equals 2. So after 2 seconds, I've dropped this ball. Boom. 2 seconds later, it's on the ground. It's at ground level 0. So what is the velocity? What is that magnitude of that speed at which it is hitting the ground? So what do I do with this 2? Plug it in right there. So negative 32 times 2 would be negative 64 feet per second is the velocity at which it's hitting the ground at that moment. That's how derivatives help us. It's pretty neat. Now, I think on homework tonight, they might even tell you like, oh, what is the velocity when the time is at, t equals 1 second? You just plug in 1 here. What is the time velocity at 1.5 seconds? You just plug in 1.5. But at ground level 0, you actually had to figure out the time. So what is the average velocity during its fall? Average velocity during this fall. I hate this question, but it actually is kind of good to make you go back. This word average, you see that word right there? So go back up here. See where I wrote average rate of change? You have to find 2 points and do an average. You have to do a slope. So what I do is I pick the one I just found. At 2 seconds, I was at 0. Actually, I should write t and s of t. At 2 seconds, I was at 0 feet. Agreed? Another one I would have, at 0 seconds, where was I? Where was the ball at 0 seconds where I initially started? 64. And then I would just do an average of those, meaning I would do a slope of that secant line. So y2 minus y1 over x2 minus x1. So 64 over negative 2 is negative 32. That's the average rate of change. And this makes sense. Again, I think we have talked about I've talked about this with you before. If you're on 45 and you get onto the on-ramp and, you're averaging about 70 miles per hour. But if I want to find it exactly, what is your speed at the exact moment of 10 minutes and 2 seconds, then I can use a derivative, okay? That's where this is all coming into play. All right, last but not least, what is the acceleration of the ball? What do I have to do here for acceleration? Look up there in your notes. Take a derivative of the v of t. Take a derivative of so you're really taking a second derivative of this. We've already taken a first. It's right here, negative 32t. So take another derivative of that. What would be the derivative of negative 32t? That's it. That's the acceleration. That's the rate, negative 32 feet per second. That's the rate at which the velocity is changing. It's the rate at which the speed is changing. It seems crazy. It's increasing. Okay, so that's an example of just physics, really, how to use it. This is another one, a different kind of example. It's about a particle moving along an x-axis. I'm not dropping it this time. I'm moving this particle along an x-axis, okay? And here's the position of it. This is the position function. They figured this out. I didn't figure it out. They did, okay? Where time is greater than 0. Why is that? Again, because you can't go backwards in time. That's just not you're not the Flash. Neither is the particle. So find v of t. What are you going to do to this guy? Take a derivative. Go ahead. So I get 3t squared minus 18t plus 24. Do you all agree? Okay, now remember, this will help you find the velocity at any point now and along the x-axis of this particle moving, okay? But here's what the question is asking. I need you to think about this. At what time is the particle at rest? It's kind of similar to what we were just talking about. What am I looking for here? What time would my particle be resting, or would my particle not have any speed? Do I put t for 0, or do I put this equal to 0? Correct. I want to know, when is this guy? This is the speed, right? I want to know, when is it at rest? When is it 0? So 3, here actually write down velocity equal to 0. That's when you're resting. So 3t squared minus 18t plus 24, set it equal to 0. Do your little factoring, because you all know how to factor, as opposed to the other children in pre-calculus. So angry at them. They refuse to watch the Amy Davis videos. Could you imagine? I actually have 2 time answers. What is my time? 2 seconds and 4 seconds. So there's 2 times where this particle is resting. It is resting at 2 seconds, takes a break, and it goes and moves again, and then it rests at 4 seconds. You all realize that 3 means nothing, right? Because somebody in the other class was asking me about that. That 3, you can just divide it out, and it doesn't mean anything. If it was 3t, though, if it was 3t, then you would have a time of 0 also. All right, so this is an interesting question. I had to go back and think about this one, and it's going to be interesting. On what time, pretty much what intervals of time is this particle moving from left to right? Again, you're on an x-axis, left to right, and then right to left. My particle needs to move from left to right, and then right to left. What do you think would happen to my velocity along the x-axis if I'm moving left to right? Would I increase or would I decrease if I'm moving left to right? When I increase, my speed, my velocity, would be greater than 0. As opposed to if I moved on the x-axis from right to left, what would happen to my velocity now? Okay? So if that doesn't make sense to you, at least write that down, because that's really the hardest part right there, is just understanding that on an x-axis going from left to right, you would be greater than 0, as opposed to going from right to left, which would be less than 0. So what you have to actually do here, which you haven't done in a while, is called a sign test. Remember, you're on the x-axis here. And your boundary points are the 2 points that you just found up here, 2 and 4. But there's another one. The other one is 0, because we can't go backwards in time. We're talking about t being seconds. We can't go backwards, okay? So I need to find out, when is my velocity greater than 0? Is it between 0 and 2? Is it between 2 and 4? Is it 4 and beyond in time? This particle, I know it seems so weird. It's moving along the x-axis, and you just want to figure out what's happening to it. So here's what you do. You do a sign test. If you don't remember where to plot the numbers, you go back into velocity function right there. And you pick a number that comes between 0 and 2. Give me a number. 1. You put 1 in here and 1 in here, and you just test the sign. What's 1 minus 4? Is it positive or negative? What's 1 minus 2? What do 2 negatives make? So it's going to be a positive right there. Do it again from here to here. Pick a number like 3. 3 minus 4 is negative. 3 minus 2 is positive. So a negative times a positive is negative. And do it again from here to here. So pick 5. You would go positive, positive. So now let's answer the question. When am I moving from the left to the right? Left to the right, I need to have a velocity that's bigger than 0. Which intervals are bigger than 0? 0 to 2 and... So I am moving, the particle is moving from the left to the right when my slope is increasing from 0 to 2 united with 4 to infinity. When am I moving from the right to the left? 2 to 4. That's the whole point of that question. Again, if you're like, I'm not going into physics, okay. FYI, I am not having this on your quiz. I will have give me velocity and give me acceleration, but I will not have moving left and right. This is really just for those of you that are headed into the engineering part of calculus and stuff like that. All right, and then last but not least, when is the particle slowing down? I'm not going to test you on this either, and I think there is a homework problem. If you do it tonight, don't do it tonight, by the way, but write this down. When your velocity and your acceleration are opposites, that's when this slows down. I'm going to do this example when we hit chapter 4. I think it makes more sense in chapter 4. It doesn't. You don't need to do it now. Okay? But write that down. When your velocity and acceleration are opposites, you are slowing down. Does that make sense to you, right? Because it'd be like positive velocity and negative acceleration would be an opposite and slow you down. All right, so that's a little bit of physics, and now we're going to do business for those of you going into business. You're welcome. Write this down, and then I'll do that last question for homework tonight. These are derivatives and how they apply to business and economics. If you can take business without doing calculus whatsoever, but most business classes require you to take what's called business calc. And here's how derivatives are applied in business class. So let me explain what all of these are first, and then we'll do an example. C of X is your cost of producing X items. Cost, that's what C of X means. It's your cost function, okay? Your marginal cost is referred to MC of X, which is the first derivative of the cost function. The rate at which your cost is changing, your cost function is changing. That's what marginal cost is. How fast is it changing, the cost function changing, or how slow is it changing, whatever. R of X, it stands for revenue obtained by selling X items. Now, there is a formula for finding revenue. Revenue is actually equal to the number of items you sell, X, times the price per item. Sometimes they call it P, sometimes they call it P of X. I'm just going to call it P, where P is the price charge for the item. Marginal revenue would be the rate at which the revenue is changing, R of X, R prime of X. And then P of X stands for profit, obviously. We want a profit, and I didn't leave room here, but this is what profit is. Capital P, not lowercase p. Lowercase p is for price of the item, whereas capital P is profit. And again, think about, Judah just sold cupcakes a couple weeks ago. And mommy had to go to the store and get a cupcake box and cupcake liners and eggs and oil and all that. That was my cost. You take that away from the price per cupcake that he sold, right? Per item. That's how you find the profit that he made. Of course, the guy, he was wearing a, Christian McCaffrey jersey, and he was like, here's $20. I was like, you ruined it. I'm trying to teach my son some math. No, I wasn't really, because he doesn't listen to his mommy. But profit is equal to your revenue, how many items you're selling at whatever price. You take away the cost. how much it cost you per item. Okay. And then obviously your marginal profit would be, take a wild guess, the derivative of that. Okay. So we write marginal profit, which is the derivative of your profit, which is the derivative of revenue minus the derivative of the cost, the rate at which the profit is increasing and decreasing. Now, I am going to do 163 for you because I'm that nice of a person, which is one of your homework problems. And it's about drills and the cost of drills. And then you only will have 4 problems left to do. Okay. And that'll be it. Let me just read it real quick and make sure that you kind of have an idea of what this is about, because I know none of you are going to open this up. Let me read it.
This is due what? This homework?
Monday.
How will you know if you did it?
What?
How will you know if you did it?
I'm going to come around on Monday and check. In general, the profit function is the difference between the revenue and the cost functions. So they gave you this in the story. You can write this down again, but this is your profit. Profit is revenue minus cost. Suppose the price, demand, and cost functions for the production of cordless drills are given respectively by P equals 143 minus 0.3x, where X is cordless drills, by the way. I know that's exciting for you. Where's Braxton when we need him?
Oh, he's out.
And P is the dollars per drill. And then they give you a C of X function. They're telling you C of X, the cost of the drill is 75,000 plus 65X, where C is your cost of producing X drills. These must be like crazy drills because it's a big cost right there, 75,000. It's a lot of cost right there. Okay. I'm gonna say exactly for a good cordless drill. Where did they get this from? All right, so here's what part A says. Part A says find the marginal cost. Find the marginal cost. Go look at your notes real quick, and what do you have to do to find marginal cost? Derivative of cost. What's the derivative of that guy right there? 65. As the rate at which it's increasing to produce a drill. Part B says find the revenue and marginal revenue. Okay, so we have to find R of X and marginal revenue, which is known as MR of X. Okay, revenue, again, if you look at your notes that I just gave you, is equal to what? What does revenue equal? Look at your notes. X minus P? X times P, okay? So you have to do X times the price of the cordless drill. So times 143 minus 0.03X. And yes, distribute that out for me because you're going to take a derivative of it anyway. So that would be 143X minus 0.03X squared. That is the revenue X, the amount of items you're selling, the price per item. And the price was a function. Now, find the marginal revenue. You take the derivative of that. What would the derivative of 143x minus 0.03x squared be? 143 minus 0.06x. Good job. Okay. Now, part C is very interesting. Part C asks us to find R prime of 1,000 and R prime of 4,000. So if you have your calculator right now, you're going to take 1,000 and you're going to plug it in where? Which function? R prime is the same as what? Marginal revenue, right? Yeah. So you're going to plug that right in there. and tell me what you get, and you are supposed to explain it to me, actually, and I'll help you out with what this means. Plug 1,000 and 4,000 in. Anybody got an answer for that one? For the first one with 1,000?
Say 80.
83. With no calc. Let me just explain what that means in terms of what we're doing in derivatives here. That means at the 1,000th drill, okay, right? We put in 1,000. We have a increase of our revenue of $83 a drill at the 1,000th drill. We have an increase in our revenue. What about at the 4,000th drill that we produce?
Negative 97.
Negative 97. What just happened there? Okay, so this is something in business that will happen. It's not actually always profitable to make more of something. Did you know that? Okay, so this is an example of, why can't 4,000 drills, you're not going to give me more money? It's not. It's actually, you're starting to go down in terms of the rate at which your revenue is coming in. And you're still making money, but it's slowing down, is what that's saying. So that's why this question is there. I think it's a kind of an interesting question, and it leads into a lot of discussions, and we'll get into more of this as we go on. But I think I'm going to actually stop right here. Find the profit, find the marginal profit, and then find P of prime and P prime of 4,000. And well, we'll just do D. Actually, we'll stop at D. Find the profit. What's the formula for profit? Look at your notes. That's why we have it. Revenue minus cost. Agreed? Okay, so take your revenue function, which you have right up here, 143x minus 0.03x squared, and you're going to take away your cost function, which is up here, right? Where my finger is. 75,000 plus 65. So I'm going to go minus 75,000 minus 65x. Do y'all agree? Can we clean this up anyway? I don't like the way that is. I'm going to put my squared first. And then what's 143 minus 65x? 78. Is that right? And then minus 75,000. And that is your profit right there. That is your profit. And all I want you to do right now is find marginal profit for me, and we're done. And you just did 163. And by the way, if you were to plug in 1,000, you are making a profit at the 1,000th drill, but at the 4,000th drill, you are not making a profit anymore. And that's just what happens in business. Again, it's one of those ideas of it's not always good to keep making more. But that's all you have to do. If you get that, you're done. You only have to do the 4 questions, which I'll pop up here again. And Braxton, we miss you.
Okay.